Okay, geometry, section 1.2. Use segments and congruence. Just a little note here. There are some very silly vocabulary words that we're going to learn in this section. Just go ahead and write them down. I would like you to know the exact definitions, even though they may seem a little silly to you. So that's my little note or public service announcement for today. Let's get to it. In geometry, a rule that is accepted without proof is called a postulate or axiom. Sort of like that undefined terms thing that we learned last section. Okay, I've told you what a point is. Now you just know what a point is. There's no real definition for a point. We just all agree that a point is a point. So when you have a rule that is just generally accepted, and I don't have to prove it to you, I'm just telling you and you just know, it's called a postulate or an axiom. We're going to use the word postulate, okay, not axiom. So if you have a postulate, it's just something that's accepted. And then we use postulates to prove other things, okay? So a rule that can be proved is called a theorem, as you will see later. So we know postulates are just generally accepted. Theorems, we can prove them. And we're going to learn all about theorems as time goes on. All right, postulate number one. Postulate number one teaches you how to use a ruler. Yes, that's true. Let's just read through it. The points on a line can be matched one-to-one with the real numbers. The real number that corresponds to a point is the coordinate of the point. The distance between points A and B, written as AB, is the absolute value of the difference of the coordinates of AB. So the ruler postulate tells you that you're going to take a ruler and put it between point A and B, and the points on the line are going to be matched one-to-one with real numbers. So the real numbers are the points on your ruler, okay? Or the real numbers are the numbers on a coordinate plane. So you can actually measure the length of this line. Okay, the distance is always the absolute value of the difference of the coordinates. So if this is x1 and this is x2, that's the x coordinate, you would take x2 minus x1, absolute value of that, and that would be your distance of AB. Now we say absolute value because you can't have negative distances. For instance, let's get blue. If x2 was, we'll say that's 3 and 1, you would do 3 minus 1, which is the absolute value of 2, which is just plain old 2. But if we had 1 minus 3, 1 minus 3 is negative 2. The absolute value of negative 2 is also 2. You can't measure something negatively. Okay, when you measure something, you actually get its length or its distance. It's always a positive number. Example 1. Apply the ruler postulate. Measure the length of segment ST to the nearest tenth of a centimeter. Okay, you guys were all supposed to purchase little rulers, so you should have one. And we're going to measure that. Hold on a second. Okay, I've got a picture of a ruler. This says measure to the nearest tenth of a centimeter. Notice this is not going to be to scale because this, watch, I can shrink it, I can stretch it, but obviously the rulers that we have in class or that you have in your backpack, you can't stretch or shrink. So we're going to do our best. We're going to line this up at the 0, and it looks like this would be, we're going to do our best to read it. That dot is pretty big, so I'm going to try to line it up in the middle of the point S. Let's see if I can read it to the middle of the point T. And when you do this in your homework and even in your test and quizzes, you're just going to have to do your best, and I'm going to give a little bit of leeway. This looks to be about 5.0 or 5.1 centimeters. Now, tenth, that means I need something after the decimal point, right? What else can I tell you about this? Notice I tried to measure from the middle of this dot to the middle of this dot. I think it's closer to 5.0, but I would accept 5.1 also. I mean, technically, if we were in a test or a quiz situation, I would probably accept 4.9 centimeters also. Okay? When 3 points are collinear on the same line, you can say that one point is between the other two. Here we have point B is between points A and C. Point E is not between points D and F because it's not on the same line. The next postulate, I have a segment addition postulate. Okay, if B is between A and C, then you can say that AB plus BC equals AC. Okay, and you can also say if AB plus BC equals AC, then B is in between them. Let's use it. The cities shown on the map lie approximately in a straight line. Use the given distances to find the distance from Lubbock, Texas to St. Louis, Missouri. So if this is a straight line and we want to figure out Lubbock to St. Louis, we would use the addition postulate and say 380 plus 360, 720 miles. First mistake of today. Uh-oh. Oh, goodness. Trying to get my right colors. There we go. I have forgotten how to add 8 plus 6. So we're good now. If you find those mistakes without me catching them, I will give you an extra credit point. Alright, use a ruler to measure the length of the segment to the nearest eighth of an inch. Okay, push pause, and please try this on your own. Okay, I did the best I could. This is difficult to do with a picture of a ruler, but if you look here, I measured to 2, and then it says to the nearest eighth. All of these little hash marks are eighths, so I counted them. 1, 2, 3, 4, 5, 6. Somewhere between 5 and 6, so I guessed at 5/8 because this next one is definitely 2 6/8, which reduces to 3/4. Remember, you can divide by 2, and you get 3/4. You try. In exercises 3 and 4, use the diagram shown below. I'm going to push pause. You're going to try it on your own. Alright, the first one, easy. Use the segment addition postulate to find xz. I added 23 and 50 and got 73. Number 4, no, because y is not between w and z, so you cannot find the distance between them. Here we have use a diagram to find GH. If you see here, we know the whole length, and we know this segment. We can use the segment addition postulate to figure out what this is. Okay, it's really the whole piece minus the little piece will give us that. Pretty simple, right? There we go. All right. Line segments that have the same length are called congruent segments. It's a very important thing to know. In the diagram below, you can say the length of AB is equal to the length of CD, or you can say AB is congruent to CD. This symbol means is congruent to. So we always know that lengths are equal, and you can say they're equal, or you can say that segments are congruent. Okay, this is pictures. Pictures are congruent, lengths are equal. Okay, write that on a note card, try to remember it, because there is a difference, and I want you to make sure you know the difference. Okay, example 4. Plot those points in a coordinate plane, then determine whether the line segments are congruent. So let's plot them. Negative 3, 4, 1, 2, 3, 1, 2, 3, 4. This is J, 2, 1, 2, 3, 4. K, L, 1, 1, 2, 3. My handwriting is awful at this point. And M, 1, negative 2. So I have JK and LM. Okay, determine if they are congruent. So I can use the ruler postulate, and since j, k are on the same point, my x-coordinate is 2 and -3. So I can say 2 minus a -3 is 5. And since L and M share the y's, I can also say that -2 minus 3 is 5. So yes, they are congruent. So we can say that JK is congruent to LM because they have the same lengths. Okay, to find the length of a vertical segment, find the absolute value difference between we already did this. We finished the problem. Okay, you try. Go ahead and push pause and find the length of WX. There we go, pretty simple. Okay, plot the points, determine whether they are congruent. Push pause. All right, I plotted the points. I determined whether they are congruent using the ruler postulate, and no, they are not. Okay, your daily homework quiz. Look, there's a ruler there for you. We have this slide and this slide. Okay, pretty simple to throw that on a scrap piece of paper or half sheet of paper, it doesn't matter to me, and put it in the inbox tomorrow, and you've earned yourself 2 points. Good job.